Computer memory. Memory plays a very important role in a computer. It is the basic unit where data and instructions are stored temporarily. Memory usually consists of one or more chips on the motherboard, or you can say it consists of electronic components that store instructions waiting to be executed by the processor. Data needed by those instructions and the results of processing the data. A computer system is also equipped with some additional memory devices which are generally used to store programs, applications, data, and information permanently. Before studying about different types of memory, let's study about memory units in a computer. Memory units, just like solids are measured in grams or kilograms, and liquids are measured in liters or milliliters. Similarly, the computer memory can be measured in bits or bytes. A computer processes and stores data and instructions in the form of two digits, 0 and 1. These digits are called the binary digits or bits. A bit is the smallest unit of information that a computer can process and store. A group of 4 bits is known as nibble, and a group of 8 bits is called byte. A byte is the minimum space required to store a character. The table given below shows the units of memory and their equivalents. 1 byte, 1 character. 1 kilobyte, 1024 bytes, about 1000 characters. 1 megabyte, MB, 1024 kilobytes, about 1 million characters. 1 gigabyte, 1024 megabytes, about 1 billion characters. 1 terabyte, TB, 1024 gigabytes, about 1 trillion characters. 1 petabyte, 1024 terabytes, about 1 quadrillion characters. 1 exabyte, 1024 petabytes, about 1 quintillion characters. 1 zettabyte, 1024 exabytes, about 1 sextillion characters. 1 yottabyte, 1024 zettabytes, about 1 septillion characters. 1 brontobyte, 1024 yottabyte, about 1 octillion characters. Byte. 1 byte is equal to 1 character. A character can be a number, letter, or symbol. 1 byte consists of 8 bits, binary digits. A bit is the smallest unit of information a computer can process. Kilobyte. 1 kilobyte is 1024 bytes. This is approximately equal to one page of text of a book. Megabyte. 1 megabyte is 1024 kilobytes. This is approximately equal to one book. 1 gigabyte. 1 gigabyte is 1024 megabytes. This is approximately equal to a bunch of books. Terabyte. 1 terabyte is 1024 gigabytes. This is approximately equal to one entire book stand. Petabyte. 1 petabyte is 1024 terabytes. This is approximately equal to a room full of books. Basically, the computer memory is divided into two types: primary memory and secondary memory. Primary memory. Primary memory is often known as the working memory or the main memory of a computer system. Primary memory is of two types: volatile and non-volatile. When the computer power is turned off, volatile memory loses its contents. Non-volatile memory (NVM), in contrast, does not lose its content when the computer is turned off. RAM and ROM are two major types of primary memory. They are made up of semiconductors material. A computer cannot run without primary memory. RAM, random access memory. RAM, also called main memory, consists of memory chips that can be read and read and read from and written to by the processor and other devices. When you turn on a computer, certain operating system files are loaded into RAM. turn on a computer, certain operating system files are loaded into RAM from a storage device such as a hard disk. These files remain in RAM as long as the computer is on. When additional applications and data are requested, they are also loaded into RAM from the storage device. The processor CPU interprets and executes a program or application instruction while the program or application is in RAM. During this time, the contents of RAM may change. RAM can accommodate multiple programs and applications simultaneously. RAM is a volatile memory. It loses its contents when the computer is turned off. For this reason, you must save the items you may need in the future. Saving is the process of copying items from RAM to the hard disk. Program instructions transfer in and out of RAM. The following steps show how program and application instructions transfer in and out of RAM. Step 1. When you start the computer, certain operating system files are loaded into RAM from the hard disk. The operating system displays the user interface on the screen. Step 2. When you run a browser, the application instructions are loaded into RAM from the hard disk. The browser's certain operating system instructions are in RAM. The browser window appears on the screen. Step 3. When you run paint program, the program instructions are loaded into RAM from the hard disk. The paint program along with the browsers and certain operating system instructions is in RAM. The Paint program window also appears on the screen. Step 4. When you exit an application such as the browser, its instructions are removed from RAM. The browser no longer is displayed on the screen. Types of RAM. Three common types of RAM chips are dynamic, static, and magnetoristic RAM. Dynamic RAM (DRAM) is inexpensive and the most popular type of main memory used in computers. Many variants of DRAM chips exist, most of which are faster than the basic DRAM. SRAM. Synchronous DRAM. It is faster and more reliable than RAM. DDR SRAM, double data rate SRAM. It is faster than SRAM and transfers data twice instead of once for each clock cycle. DDR2. It is the second generation of DDR with faster speed. DDR3. It is the third generation of DDR which is designed for computers with multi-core processor. It is faster than DDR2. DDR4. It is the fourth generation of DDR which is faster than DDR3. Static RAM (SRAM) is efficient and sorry RDRAM, Rambus RAM. It is much faster than SRAM. Static RAM (SRAM) is efficient and fast but is very expensive. SRAM is used in small amounts as cache memory. In a computer, cache memory improves the performance of a computer by storing the data which the computer frequently uses. Magnetoresistive RAM is a newer type of RAM which stores data using magnetic charges instead of electrical charges. Its manufacturers claim that RAM has greater storage capacity, consumes less power, and has faster access time than other RAMs. Retains its contents after the computer is switched off, which could prevent loss of data for users. Memory module. A memory module is a circuit board that holds memory chips. RAM is a type of memory chip that makes up the main memory in the computer system. Two types of memory modules are SIMs and DIMMs. A single inline memory module SIM has pins on opposite sides of the circuit board that connect together to form a single set of contacts. With a dual inline memory module DIMM, by contrast, the pins on opposite sides of the circuit board do not connect and thus form two sets of contacts. RAM requirements. The amount of RAM on the computer determines the amount of programs and data a computer can handle at one time, which affects the overall performance. A computer can only manipulate data that is in its main memory. More the RAM, faster the computer will respond. ROM, read only memory. ROM refers to memory chips used for storing data that can be read only. The data on ROM chips cannot be modified, hence the name read only memory. ROM is non volatile, its contents are not lost when the computer is switched off. ROM chips contain data, instructions, or information that is recorded permanently. For example, ROM contains the basic input or output system BIOS, which is a sequence of instructions the computer follows to load the operating system and other files when you first turn on the computer. Many other devices also contain ROM chips. For example, ROM chips in many printers contain data for fonts. Manufacturers of ROM chips often record the data, instructions or information on the chips. When they manufacture them, these ROM chips are also called firmware. Some of the variations of the ROM chips are a programmable read-only memory (PROM) chip is a blank ROM chip on which you can place items permanently. Programmers use micro microcode instructions to program a PROM chip. 2. An erasable programmable ROM (EPROM) is another type of ROM, the contents of which are erased by ultraviolet light and then reprogrammed by a PROM program. 3. An electrically EPROM EEPROM is another variation of the PROM which allows a programmer to erase the microcode with an electric signal. Cache memory. Cache is a temporary storage area for instructions and data that enhances CPU speed. Most of today's computers improve their processing time with cache memory. Cache improves the processing speed of the computer because it stores frequently used instructions and data. Cache is built directly in the processor chip. Most modern computers have three types or layers of cache memory: Level 1, Level 2, and Level 3. Level 1 cache is built directly on the processor chip. It usually has a very small capacity. Level 2 cache is slightly slower than Level 1 cache but has much larger capacity. Level 3 cache is a cache on the motherboard that is separate from the processor chip. When the processor needs an instruction or data, it first searches cache in the order L1 cache and then L2 cache and then L3 cache. If it doesn't locate the item in cache, then it searches RAM. If the instruction or data is not found in RAM, then it searches in a storage device such as a hard disk. Secondary memory. Secondary memory is used to store data for a long time. It operates at a slower rate than primary memory. This memory is permanent in nature, i.e., data stored is not lost even when the computer is switched off. So, it is even known as non volatile memory. It is also known as backup memory. The main example of secondary memory is hard disk. So, this is your chapter. Thank you.